Now let us take examples based on Lagrange's interpolation and Newton's divide difference interpolation. First example, given f of 2 equal to 4, f of 2.5 equal to 5.5. Find the linear interpolating polynomial. Find the linear interpolating polynomial. Using first question, using Lagrange's interpolation, and second one, Newton's divided difference interpolation. Hence find an appropriate value of or approximate, you say, one can say approximate value of f of 2.2. Solution. See what is the given f of 2 equal to 4 and f of 2.5 equal to 5.5, right? That means what? The data is given like this, x versus f of x. Actually tabular form is better. Instead of given data 2 and one more is what? 2.5, and corresponding function value f of 2 is 4, f of 2.5 5.5. Therefore what is x0 value? 2, and what is x1 value? 2.5. Therefore f of x0 is what? 4. F of x1 is what? 5.5. I think you can understand this clearly. x0 is 2, x1 is this one, so f of x0 and f of x1 value. Okay, now what is the first question answer? Lagrange's interpolation. What is the formula? Lagrange's interpolation for the data. Only 2 points are there now. For the data x versus f of x. What is the data? x0, x1, f of x0 and f of x1. What is the Lagrange for the data? Lagrange's interpolation, Li stands for Lagrange's interpolation is, what is that? P of x or P1 of x, first polynomial, linear. 1 stands for linear. What is the formula? L0 x into f of x0 plus L1 x into f of x1. That's the linear interpolating polynomial Lagrange's, where what is L0? You know, P1x. L0 means what? This is x minus x1 by, in denominator replace x by x0. Okay, this is multiplied by f of x0. And what is L1? X minus x0 by, replace x by x1 in denominator. That's it, f of x1. So substitute all the values. What you will get? This is x minus x1 2.5 and x0, that is 2, minus 2.5. What is f of x0? 4, plus x minus x0 by x1 minus x0, right, into f of x1. What is that? 5.5. Okay, after simplifying you will get p1x equal to p1x linear polynomial is equal to what? 3x minus 2. This is Lagrange's interpolation. And what required is what? F of 2.2. Required is f of 2.2. Okay, therefore what is f of 2.2 becomes now? F of 2.2 is nothing but p1 of 2.2, approximate polynomial. F is exact and it is approximated by Lagrange's polynomial p1. So p1 of 2.2 is 3 into 2.2 minus 2. Okay, this value is 4.6. Next one, Newton's divided difference formula. Newton's divided difference. Newton's divided difference formula. What is this formula for the length of data 2? Okay, for the length of data 2, what is the formula? This formula is what is p1 of x equal to p1 of x equal to f of x naught, right, plus x minus x naught into the first divide difference x naught x1, the first divide difference, where what is the first divide difference formula? F x naught x1 is equal to what? F of x1 minus f of x naught by x1 minus x naught by x1 minus x naught. And what is f of x1? 5.5, isn't it? 5.5, and f of x naught 4, and this is 2.5 minus 2. So the first divide difference value is 3. Now everything you know. Therefore, what is p1x is equal to f of x naught plus x minus x naught into the first divide difference. This is equal to, what is f of x naught? 4, plus x minus x naught is what? 2, and what is the first divide difference? Just we calculated, that is 3. After simplification you will get 3x minus 2. This is also 3x minus 2. Therefore, what is the approximate value? F of 2.2 is nothing but p1 of 2.2. This is, you are getting 3 into 2.2 minus 2. 3 into 2.2 minus 2. The value is again 4.6, right? See, that polynomials structure is different, but the polynomial is unique always. Polynomial is unique always. Okay, this is one simple problem. Now let us take a problem using errors. Second problem, using the data sine of 0.1 equal to 0.09983, sine of 0.2 equal to 0.19867. Find an approximate value of sine 0.15 by Lagrange interpolation. Obtain a bound on the truncation error. Okay, this is the problem and solution. First, let us find the Lagrange's polynomial. Okay, for the given data. What is the given first? Given sine of 0.1 equal to 0.09983. Next one is, only one more point is given, sine of 0.2 equal to 0.19867. So what is the data is given? X versus f of x. What is f of x is given as sine x, right? This is x naught value, I am directly writing here 0.1, and x1 value 0.2, right? And what is this f of x1? F of x naught 0.09983 and 0.19867. This is the given data. So one more thing I am writing clearly. What is x naught here? X naught is equal to 0.1, and f of x naught is equal to what? 0.09983. x1 equal to 0.2. f of x1 is what? 0.19867. Therefore, for the data, the Lagrange interpolating polynomial is what is the formula? P1x equal to L naught x into f of x naught plus L1 x into f of x1, right? And what is L naught? X minus x1 not diff, and replace x by x naught, this is f of x naught. And what is L1? X minus x naught and replace x by x1, okay, f of x1. So substituting all these values, x minus 0.2, x naught minus 0.1 minus 0.2 into 0.09983 plus x minus 0.1 by x minus 0.2, so sorry, x1 means 0.2 minus 0.1, this is 0.2 minus 0.1 into f of x1, 0.19867. So after simplifying all this, and the question is what? Directly find an approximate value of sine. Okay, so one can write directly, therefore what is the approximate value of sine 1.5 at x equal to, you can write directly without finding polynomial, directly required value is given, p1 of 0.15, p1 of 0.15, which is equivalent to sine of 0.15, okay, equal to 0.15 minus 0.2 by negative 0.1, 0.09983 plus 0.15 minus 0.1 by, this is 0.1, 0.19867. So this value is finally 0.14925. See, in this problem directly what is the question? Find approximate value of what? Sine of 0.15. So after writing this polynomial p1 of x without finding polynomial expression, you can directly put x equal to 0.15. So no need to find polynomial expression here. Is that clear? Right? Okay. Now what is the truncation error bound we have to find? Now the truncation error in Lagrange linear interpolation is, what is the formula? Already told you, this is E1 of fx is equal to, what is the formula? 1 by 2 into, what is that, x minus x naught into x minus x1 multiplied by f double dash I, this is truncation error. And the bound, and what is the bound? And the bound is, what is that? Modulus of E1 of f of x is less than or equal to how much? 1 by, what is that value? Less than or equal to 1 by 2, yes, maximum over x naught less than or equal to x less than or equal to x1 modulus of x minus x naught into x minus x1 into m2, where what is m2 value? M2 is maximum of, what is the value? M2 is the upper bound, one can say. M2 is upper bound of f double dash x, that is, what is that? That is mod f double dash x is less than or equal to m2 in m2 in, what is the interval? x0 comma x1, remember this is the truncation error. And what is the bound? This equality becomes what? After taking modulus on both sides, less than or equal to, and this f double dash xi, we are, for f double dash x we are considering maximum upper bound, that is m2 value is placed here in place of f double dash xi. Therefore What is the first one? Let us find E1. E1 of fx is equal to, what is that? 1 by 2 x minus x naught. What is x naught value? 0.1. And next one, x minus x1, 0.2. 0.2. And what is f of z is what? F of x is what? Sin x. So f dash z, f dash x is what? Cos x. And f double dash x is what? Minus sin x. So f double dash xi means what? Minus sin xi. Minus sin xi. Where what is interval here? What is interval is given as 0.12 in 0.1 less than xi less than 0.2. 0.1 less than xi less than 0.2. Okay. And here the maximum value, here the maximum value of what we have to find? Maximum value of f double dash xi, mod f double dash xi is mod sin z, right? Mod sin z in what interval? In the interval 0.1 comma 0.2. In the interval 0.1 comma 0.2. This is less than or equal to, xi belongs to, or in xi belongs to this one. And when calculate sin z, mod sin z value at xi equal to 0.1 and 0.15, midpoint, and 0.2, midpoint of 0.1 and 0.2, 0.15, right? This is 0.3, yeah, 0.15. Then maximum value exists at x equal to 0.2, x equal to 0.2, and is sine of 0.2 equal to 0.19867, 0.19867. Therefore mod f double dash xi less than or equal to m2. What is m2 value? 0.19867, 0.19867. This is m2 value. Therefore the bound on the truncation error, the bound on the truncation error is, what is that? Modulus of E1 of fx is less than or equal to what? 1 by 2. And remember here we are writing maximum of what? X minus x naught. What is that? X naught 0.1, x minus x2 0.2, isn't it? And what is the maximum value here? m2 19867. Okay. And here what? This is 0.1 less than x less than 0.2, isn't it? Right? Less than or equal to. And in theory we know we have maximum of mod x minus x naught into x minus x1 exist at what point? Already we discussed at midpoint. At a midpoint x equal to x naught plus x1 by 2. Now for this, what is that? 0.15. Therefore what is E1 of fx is less than or equal to 1 by 2 modulus of what? This is 0.15 minus 0.1, 0.15 minus 0.2, right, into 0.19867 is it equal to, this is finally 0.00025. This is the error bound, truncation error bound. Okay, is that clear? Okay, now take another problem. Determine the step size h. Determine the step size h that can be used in the tabulation of f of x equal to sin x in the interval 1 3, so that the linear interpolation will be correct to 4 decimal places after rounding. 4 decimal places after rounding. Okay, solution. Now seeing here, we have to determine step size and the accuracy is given. What is that? 4 decimal places. Therefore what we have modulus of E1 of fx is less than or equal to what? In terms of h, we have 1 h square 1 by 8 h square. Do you remember 1 by 8 h square? What is this? M2, I think, right? H square, or maximum of f double dash x. Maximum of f double dash x, where a less than or equal to x less than or equal to b. Okay, less than or equal to b is less than or equal to epsilon. Remember this expression, we have already derived this. Okay, where x1 minus x0 is h, x2 minus x1 is h, like that. Okay, now coming to the problem, what is given? F of x equal to sin x. So f dash x equal to what? Cosine x. F double dash x is what? Minus sin x. And let us find maximum value. First, maximum value of a less than or equal to x less than or equal to b of f double dash x is equal to maximum of 1 less than or equal to x less than or equal to, this is 3 mod sin x is equal to how much? 1. That means, that is sin x has, or you can write like this, sin x in 1,3 sin x has maximum value. What is the maximum value of sin x? Always 1. Okay, in positive interval 1,3. So maximum value 1 here, right? Therefore what is this equation becomes? Therefore what is the error bound? Therefore error tolerance, write like this: if epsilon is the error tolerance, then we have h square by 8 maximum of f double dash x. What is this interval? 1 less than or equal to x less than or equal to 3 less than or equal to epsilon, where what is epsilon is given? 4 decimal accuracy. 4 decimal accuracy means what? This one, 4 zeros 5, 4 zeros 5, 5 zeros. 2 decimal accuracy means 0. Just wait, this one can write where 4 decimal accuracy, 4 decimal places accuracy is required. Therefore what is epsilon value? 0.405. Nothing but one can write 5 into 10 power minus 5, right? 5 into 10 power minus 5. Therefore we have h square by 8 into maximum value of what? Sin x in 1 to 3 1 less than or equal to how much? 5 into 10 power minus 5. This h square is less than or equal to 40 into 10 power minus 5, right? Isn't it? So what is this h value? H is less than or equal to 0.02. Okay, h is less than or equal to 0.02. Therefore step size, h means what? Step size. How you calculate this one? Take logarithm on both sides, simple expression, right? Okay, take logarithm on both sides for this. After simplification, you write, after simplification we get h less than or equal to 0.02. How to solve this? H square less than or equal to 40 into 10 power minus 5. Take logarithm on both sides and simplify. You will get h is less than or equal to 0.02. Now another problem. The function f of x equal to sin x is defined on 1 3 interval 1 3. Then first question, obtain the Lagrange linear interpolating polynomial, Lagrange linear interpolating polynomial in this interval and find the bound on the truncation error. Obtain the approximate values of f of 1.5 and f of 2.5, f of 1.5 and f of 2.5. Another problem, second, in this one same, divide the interval 1 3 into two subintervals 1 2 and 2 3. 1 2 and 2 3. Obtain Lagrange linear interpolating polynomial, in each subinterval and find the bound on the truncation error. Hence find the approximate values of same f of 1.5 and f of 2.5. Here there are two problems. The function is given as sin x. The function is given as f of x equal to sin x. Function is given. And what is the interval? First interval is given as, for the first problem, 1 comma 3 is given. So find the data. I am giving x versus f of x. Let us write 1 3. That's it. What is sin 1 value? Sin 1 equal to, and this is sin 3 equal to. Sin 1 value is 0.8415. Sin 3 value is 0.1411. So here, what is x naught? First value x naught 1. F of x naught is how much? 0.8415. x1 value is 3. F of x1 value is what? 0.1411. So first polynomial. Therefore, Lagrange linear interpolating polynomial is P1x, right? P1x, what is the formula? L0 x into f0 x plus L1 x into f1 x, right? So what is this? X minus x1 by x naught minus x1 f naught of x, sorry, f of x naught. This is f of x naught, f of x1, f of x naught plus x minus x naught by x1 minus x naught f of x1. So this is x minus x1, that is 3, by x naught 1 minus 3 f of x naught 0.8415 plus x minus 1 by 3 minus 1 f of x1 means f of 3 sine 3 1411. So this is equal to, what is the polynomial here? You will get finally after simplification. This is 0.p1x equal to minus 0.3502x plus 1.1917. Okay, this is over. Next one, what is the, we have to find, question is, what is the question? Truncation error, bound on the truncation error we have to find. Now bound on the truncation error is, what is the formula? E1 of fx is less than or equal to 1 by 2, right? Maximum of 1 less than or equal to x less than or equal to 3 mod x minus x naught x minus x1, right? Then into m2. What is m2? Where m2 is determined by what is that? Maximum of f double dash x in 1 less than or equal to x less than or equal to 2 less than or equal to m2. So maximum value of f double dash x is the value of m2, upper bound. M2 is upper bound. Therefore, first, what is f of x? Sin x. So f dash x cosine x, f double dash x minus sin x. Therefore, mod minus sin x. Okay, maximum in what is our interval? 1 3 is the interval. So in 1 3, what is the maximum of this sin value? 1. Range of maximum range of sin x is minus 1 to plus 1. And what is the range here? What is the domain here? 1 to 3. So obviously maximum value is 1. Therefore, okay, this is m. Therefore m2 equal to 1. So I will write that bound on the truncation error is less than or equal to 1 by 2, right? Maximum of 1 less than or equal to x less than or equal to 3 mod x minus x naught x minus x1, and what is m2 value? 1, and maximum of x minus 1 x minus 3 exists. What is in the theory? I already told you, exist at midpoint. Of 1 3, that is x equal to 1 plus 3 by 2, that is 2. Therefore final answer. Therefore, what is the error bound? Truncation error bound is less than or equal to 1 by 2. What is this value? 2 minus 1. Maximum I am considering directly. 2 minus 3 into 1. So this is less than or equal to how much? 1 by 2 mod, this is 1 and minus 1, and this is 1. So this is 0.5. This is 0.5. Therefore, truncation error bound, what is the value? Fx is less than or equal to 0.5. Is less than or equal to 0.5. And another one we have to find. What is that? F of 1.5. F of 1.5 is nothing but what? P1 1.5. What is P1 of x? Minus 0.3502 into x. X value taken as 0.5, 1.5 1.1917. So this value is 0.6664. And what is another one I'm taking here? Another one, f1 of 2.5 is required. That is nothing but p1 of 2.5, that is equal to minus 0.3502 into x value 2.5 plus 1.1917. So this value is 0.3162. This is the first case over the interval 1 comma 3. Okay, now case 2, what is that? Divide the interval 1 3, divide the interval 1 3 into subintervals 1 comma 2 and 2 comma 3. Now in each subinterval we have to find Lagrange's polynomial, right? First in 1 comma 2, in 1 comma 2. Okay, what is x naught is 1. What is f of x naught? Sine 1. What is sine 1 value? This is 0.8415. Done. Next x1 is what? Not 2 now, f of x1. So sine 2 value 0.9093. This is over. Okay, so what is the data here? X versus f of x. X naught value 1 2, this is 0.8415, 0.9093, right? Therefore Lagrange's interpolating polynomial, Lagrange's interpolating polynomial is p1x equal to L naught x into f of x naught plus L1x into f of x1. So this is x minus x1 by x naught minus x1 into f of x naught plus x minus x naught by x1 minus x naught into f of x1 formula. This implies p1x after substituting x minus x1 2 by x naught minus x1, this is negative 1 multiplied by 0.8415 plus x minus 1 by x1 minus x0, this is 1 multiplied by 9093, right? This implies what I am getting, p1x equal to Lagrange's linear interpolating polynomial after simplification 0678x plus 0.7737, and let me find directly p f of 1.5. f of 1.5 is nothing but p of 1.5, p of 1.5, 0.0678.1.5 plus 0.77737, and this value is in 1 comma to 1.5 na 0.8754. Here 1.5 belongs to interval 1 comma 2. 2.5 is there. 2.5 not belongs to 1 2, so don't calculate here. Now error, truncation error bound, truncation error bound, truncation error bound or error bound is e1 of fx is less than or equal to 1 by 2. Maximum of 1 less than or equal to interval is 1 to 2, x minus x0, x minus x1 into m2, where maximum of 1 less than or equal to x less than or equal to 2, f double dash x is less than or equal to m2. m2 is upper bound of f double dash x. m2 is upper bound of f double dash x. This implies maximum over 1 less than or equal to x less than or equal to 2 mod sin x is always less than or equal to 1. Okay, or one can write first equal to 1. Therefore what is m2 value? Maximum upper bound 1. Now what is the error bound in the interval fx less than or equal to 1 by 2, where maximum exists at what point? Midpoint of 1.2 shall. Okay, let me write one more step. What is that? Okay, let me write this once again. Maximum of x minus x0, x minus x1 in 1 2 exist at midpoint. Exist at midpoint x equal to 1 plus 2 by 2 3, that is 1.5. Therefore, what is the error bound? E1 of fx is less than or equal to 1 by 2. I am writing directly. What is this one? 1.5 minus 1, 1.5 minus 2. And what is the maximum value of this in 1 to 1? Okay. So what is this? Equal to 1 by 2. This is 0.5. You will get here 0.5. And here you will get minus 0.5. So this is equal to 1 by 2, 0.25. So this is E1 of fx is less than or equal to 0.125. 0.125. This is the first case. And now in the interval, in what interval now? 2 3. In interval 2 3, okay, that means x naught is what? 2, x1 is what? 3. So what is f of x naught? F of x naught is sine 2. What is sine 2 value? 0.9093. And f of x1 value is what? Sine 3. This is 0.1411. 0.1411. Right? Now this is the change. Data is what? X versus f. The data is 2 3.9093 and here 0.1411. Now we have to calculate Lagrange's polynomial. Therefore, Lagrange's interpolating polynomial is P1x equal to L0x into f of x naught plus L1x into f of x1. That implies P1x equal to, again same formula, x minus x1 by x naught minus x1 into f of x naught, x minus x naught by x1 minus x naught into f of x1. Substitute all the values. Okay, this is x minus x1 is 3 by this is 2 minus 3 into f of x naught, that is sine 2 value plus x minus 2 by 3 minus 2, this is sine 3 value. So after substituting all the values, the polynomial is minus 0.7682x plus 2.4457. Now what is required? 2.5 is required, right? So P1 of 2.5 is equals to, this is minus 0.7682 into 2.5 plus 2.4457. This value is 0.5985. Now error bound. Same formula, E1 of fx is less than or equal to 1 by 2 maximum of, now what is the interval? The change is this, that's it, x minus x naught, x minus x1 and m2. Okay, and what is m2 here? Maximum of 2 less than or equal to x less than or equal to 3, f double dash x. What is this value? Maximum of 2 less than or equal to x less than or equal to 3 sin x. Mod this minus is there, doesn't matter. Okay, so this value, what is the simplification value? Maximum value here sine 2 you will get. Already we have seen here. Sine 2 value is what? Clearly in 2 comma 3, sine 2 value is what? 0.9093. Whereas sine 3 value is what? 0.1411. So maximum value is this one. So sine 2, this is the maximum value, 0.9093, and this is the value of m2, maximum upper bound. And maximum of x minus x naught into x minus x1 exists at midpoint. Of what is interval now? 2 3. Midpoint of 2 3, that is x equal to 2 plus 3 by 2, that is 2.5. 2 plus 3 by 2, 2.5. Therefore, what is this value finally? Therefore, error bound, truncation error bound is less than or equal to 1 by 2. What is the maximum value? 2.5 minus 2, x naught is 2, 2.5 minus 3, and what is the error value? Sin 2. Sin 2 is m2 value, so less than or equal to 1 by 2 mod, this is 0.5 and this is minus 0.5, and sin 2 value is what? 0.90. What is the sin 2? 9093, 9093, isn't it? Right? So what is this finally? This is 1 by 2 0.25 into 0.9093. This is equal to less than or equal to, and here equal to 0.1137. Therefore, in the second interval, the truncation error bound is less than or equal to 0.1137. This is the problem. Okay, right? This is one more problem based on Lagrange's interpolation and the truncation error bounds.